Hello viewers, I'm back with a dynamic programming problem, coin change, and in this problem I'll try to highlight one of the ways you can go wrong while trying to execute dynamic programming. Dynamic programming, as you may know, is a class of problems where you can break the problem into a recursion and use existing solutions to form the next step of solutions. And this problem of coin change is basically stated as you're given an amount x and coins set y1, y2, yn. How many ways there are to make x from these coin sets? And these are unique ways, not permutations, but unique combinations of these coins. And assuming you have infinite supply of coins, obviously here. So the problem that when I execute this incorrectly, the problem is that you may try to execute the recursion in such a way that you will basically start from x, some small value of x, let's say x equals 0, and in this problem we assume that for x equals 0 the number of ways is 1, and that's just convention because it helps break the problem correctly. Any other value depends on the ways of 0, and therefore you can form the larger problems from the smaller problems. So just assume ways of 0 is 1, which is here. Now when you go to other values like 1, 2, 3, 4, they will not be possible using these coins, so the answer there would be 0. But when you get to 5, when you take one coin of 5 out, then it becomes a problem of making the remainder with the known smaller problems, and the only known smaller problem here is the ways of 0, and we can say that it'll be the coin 5 taken out with ways of 0, which is 1, so there is one way of making this. When you get to 10, it's if you approach it by using coin 5, and if you take out 5, then remaining is 5, so ways of 5, which we know here is 1, and then if you take out 10, then it's ways of making 0, which is 1. So we know that this answer is 1 each on these, and therefore the answer here is 2. When you get to 15, you see that, and so this is 1, so let's just write that here. This answer is 1 ways, and this answer we know now is 2 ways. And so when we get to this 15, what happens is that you will say, let's try coin 5, and yes, 5 can go in there, so remainder is 10. So how many ways to make 10? And you see here it's 2 ways. So it's 2 ways to make this part, and then when you try 10, you remove 10 and remainder is 5, so ways to make 5 is 1, so this gives you 1. So you get 2 options here but 1 option here, and basically the answer then is 2 plus 1, 3, and therefore the problem here becomes that you have 3 ways of making 15, which is not true. 15 can only be made as 5, 5, 5 or 5, 10. 10, 5 is really the same as 5, 10, so it's not really an answer, and therefore this is coming out as the wrong answer. Now we can approach the problem correctly by doing something different. I'm going to skip a couple slides to show you what the problem here is. The problem here is that, you know, we have this two-dimensional matrix and the x values are going from 0 to 300, and these are our coins 5, 10, 25. What we are trying to do here in the wrong approach is that we are trying to solve this, and we are trying to solve x equals 5 for all the values before moving to x equals 10 and 15 and so on. We're trying to solve this. This is an incorrect approach. You're supposed to solve it in this dimension, so y equals 5 all the way, and that way when you bring the coin 10, there's not already a strange permutation going on here. All the 5s are there, then you layer it with 10, then you layer it with 25, and it works. So let's go back and check that. The method 2, we first try 5, and originally, as you can see, there's 0 ways. Everything is initialized to 0, and so there's 0 ways of doing anything. Now when you bring the coin 5, you basically take 5 out of 5, so there's 0 ways of doing 0, and so you get a 1 way because ways of 0 by convention was 1. When you try 10, you take 5 out of the remainders 5, ways of 5. Now ways of 5 now has become 1, so it's basically 1 way here. And then you go to 15. 15, if you take out 5, ways of 10 is 1, therefore you get 1 way here. Now you stack on the next layer. So you copy all the original ways. Now after running 5, you have 1, 1, and 1 here. Now you bring the coin 10, and 10 obviously doesn't go, so no change here. But 10 goes here, and if you take 10 out, the remainder is 0, and 0 is one way. So you have 1 already existing, and when you try to bring in 10, you get 1 more way, so total is 2 ways. And when you do 15, 15 is already has a one way with coin number 5. When you bring 10, you take out 10, remainder is 5 ways of 5. Here is one way, so this whole thing is one way, and 1 plus 1 is 2 ways. So here you have the right answer, and the right answer comes because there are no permutations this way. And therefore, in summary, the right way to do coin change problem is on the x-axis you can lay out your x, which is the bucket value, which goes from 0 to the max value that you need, and on the y-axis you can lay out your coins. And with these coins you have to go one coin at a time, all the way, all the values, and then lay the next coin, and then lay the next coin and on top of it, and so on and so forth, and that'll give you the right answer. So hoping this helps some of you who are playing with the dynamic programming problems, and helps you understand. It's always good to play with examples and to see different approaches and see what works, what doesn't. Dynamic programming can be challenging sometimes, but as they say, the more you practice, it eventually gets easier. So thanks for watching, and catch you another time. Take care. Bye-bye.